So we are presenting on the Wolbachia project.
So Wolbachia is a bacteria that infects insect populations. It infects approximately 20% of all insects. What's notable about it is that it feminizes insect populations, meaning it makes them female. So it does this through sterilization, the killing of male larvae, parthenogenesis, which is asexual reproduction, and feminization, which is changing male insects into female ones. It's also important because it's been implicated in human river monkeys and heartworms in dogs, and it can also be used for types of disease and pest control.
Why does feminization help propagate this thing?
Well, since it can asexually reproduce, what it does is it's also that parasites are generally more effective in a female, or at least that's what we've seen. So when they make the insects female, it helps them find hosts, and they tend to be more harmful.
Really?
Yeah. I mean, that's what you see in the mosquitoes.
You good?
Yeah.
Alright, so the primary objective of this project is going to be giving kids lab experience. So the labs are broken up into 5 portions. The first is going to be insect identification, and we will ask students to collect their insects for a larger diversity. And we will be using this link right here to help us identify our specific insects. After we identify, we'll then be going to DNA extraction, in which we will be matching up the insect to extract the DNA. And then that will be prepped for PCR, in which we'll be amplifying the amount of DNA, and that will be in preparation for gel electrophoresis. At this step, this is where you're going to be indicating and finding out whether your insect is infected with Wolbachia, and that will be ran with various controls, including a wasp with a negative control, so no Wolbachia DNA, a wasp with positive control, so it will be infected, and then pure Wolbachia DNA. And if your insect has been tested positive for Wolbachia infection, it will then be prepared and then sent into the marine biological lab for bioinformatics and sequencing. And then afterwards, when you get your sequences back, you'll be then running a bioinformatics lab using various NCBI BLAST databases. Any questions?
I have a quick one. So you mentioned that you're collecting insects. I saw you had a really nice arthropod of a non-insect variety. So is it insects specifically, or also like spiders?
Spiders are
arthropods. Okay.
Yeah.
My understanding is that the arthropods do not have Wolbachia, is what has been thought, but last year.
That non-insect arthropod?
Yeah,
Okay.
yeah. Some students found a spider that had tested positive for
Ooh, very
Wolbachia, so
interesting.
it's interesting, and I'm interested to see what you guys find.
Yeah. Okay. Cool.
Right, so we think this is important, first of all, because it'll replace Walksman, and it's also going to give kids lab experience without putting any other iRT projects at risk. We also think that if students can find new strains, it gives them the potential to interact with university professors about what they found, and it gives them the opportunity to add to a database of Wolbachia strains.
Alright, so our current timeline for the fall and winter term is that for this month, Mariel and I will be just ourselves doing troubleshooting and running the lab procedures, and we can start next week. We just received the shipments of the controls. And then after that, we'll be piloting the labs in both AP bio classes, so that'll give us about 36 samples to run through. In November, we'll begin project meetings for those interested and begin practicing and teaching lab protocols. Afterwards, and simultaneously, we'll be assigning students to collect insects, and then we'll have the students run insect identification. Yes?
How many student participants do you think you'll get, or would you like?
We are opening it up to all grades, so we'd like to see about 50.
So you're going to run 200 reactions. So if you figure your PCR and the controls per student,
Sorry.
if you figure out your controls, and then you have 50 kids, you have 4 reactions per student.
Right.
You're going to do 200 PCRs, 200 lanes and gels.
Yes, and then we can split that up onto multiple days.
You're responsible for all these kids.
Okay. And then late November, December, we will be running the DNA extraction, PCR, gel electrophoresis, potentially either on multiple days or on one day, because last year we tried running all the labs for Woxman all in one day, and it worked out pretty well. And then all the positive Wolbachia samples will then be prepped and then sent for MBL for sequencing. And budgeting, just,
Why MBL?
they're the ones that run this program.
Okay,
And
so
then-
it's just,
Yeah,
they'll do it for you
Yeah.
for free?
yes, for free.
Oh, that's
Just-
wonderful.
Yeah, early notification, yeah. And so the total budget for 50 students is $600. Mr. D told me we had a hard tissue homogenizer, and so that will add $1,200 for the pin removal set, and then for a vial set. This budget is in a shared folder, only with the teachers.
Do you need a homogenizer for this,
We
or
do
could
not.
you just,
We could do
I mean, mash it?
yeah, we could do that too.
That's seems easy when you're talking about 50 kids.
50 kids, yeah.
I think we have these little blue, like,
Yeah.
sticks that you can
The
just mash.
muscles, yeah.
Yeah,
Alright. The Nasonia wasp controls are for free. We just got our shipment today. And we also have materials from last year's for troubleshooting. And we will need to clarify budgeting on homogenizer if we so choose to use it. For lab protocols, we can either separate it over multiple days, or we can do it on one day, most likely on the weekends. And it does not need to be done in the lab next door. And sequencing will be sent to MBL, and will take about 2 to 4 weeks. That's it.
You're gonna have 50 kids in here at one time.
We can choose to separate it onto multiple days.
Show me what that looks like. You have 2 days, 2 weeks, how do you separate this? So like even then you have, I mean, Dr. Kirkhart and I ran basically this procedure with the two of us and 30 kids. And it was tough.
I think what we're all getting at here is that you may wanna think about scaling it back,
Scaling it back.
at least for right now.
Okay.
Working with that many students at one time that don't, remember that they don't know what they're doing.
Okay.
And you could potentially open it up if someone wants to do some collecting and identifying, and then that's it. Or, I mean, I don't know how involved they have to get, but if someone wanted to be helpful maybe a little bit, like maybe some of the lower grades, and then you just like build up your sample bank and then kind of go through the actual experiment as you can with who you have.
So just so you get an idea of what this looks like, from what it seems like you're saying, it's gonna be basically 2 kids per gel box.
Yeah.
Right? So
Even that's a lot,
of
yeah.
gel boxes.
So scaling it back, maybe,
How many kids did you have for Watchmen last year?
I believe 20, 25.
How did that go?
It went well, I
Was it
thought.
alright to have 20, 25 kids?
Yeah, and then we split it between the lab and then the room next to it.
Wait, how successful were you?
In what sense, running the labs?
Yes.
I think all samples were good, maybe 1 or 2.
You guys got, you guys PCR'd samples?
Yeah.
You got product and submitted it?
Yes. And those were sequenced.
Yeah, I mean, I think they did, but.
Yeah.
What's that? I don't know, I wasn't involved.
Are you sure about that?
Yes.
We sent them to.
We sent them.
Rutgers.
And those were sequenced.
And then they sent
I
it
think
back.
you may find that this is a little bit more, because there are multiple sets of primers to use here also.
I believe so.
Yeah, so it might be a little more complicated.
What's your DNA isolation protocol look like? What are you using?
I believe Chaogen,
Collagen.
Kaigen.
The DNA
Is
is
there
easy.
Is there something you're doing before that, or do you go just right from the start?
I believe straight into
Insect
it.
to the protocol. That part of it was fairly smooth last year, so once we did it. But they also didn't get 100% success on the rest results either. So remember, even if you have all these things, and there's a really good chance that a lot of them won't be successful at the beginning, so then you're running into repeating it over and over again, which kids.
Yeah, I would suggest maybe 5.
I was thinking like 10, 15, is not where I was.
Let's call it 8, 10.
You know, I mean, this is a
Just
new,
to start.
new project too, so you don't know how many kids you're gonna get right off the bat anyway. Though I have heard some people ask me about it already, so, there's
Yes,
interest.
same.
Okay.
But I think because it's a new project, you guys might be better off limiting your numbers. If it works great,
Yeah, then you can ramp it up.
Okay.
then, you know,
You just don't wanna overcommit too much at the beginning and then have 50 people in here trying to organize it, and then everything breaks down and.
because you
So-
guys also have other things to do, I would imagine, besides run this for
How are
your
you-
full-time
I'm sorry.
job.
How are you gonna pick your kids and where is this all gonna be done?
I think what we can do for selection is running like Luxman last year, have a small application, have them answer some questions. And then for room, we can choose this room over the next door.
Okay,
Any other
thank you.
questions?
Oh, yeah.
I would add